Hi guys, this is CodeFilms. Welcome to another CodeFilms. In this code film, we're going to look at payload encryption, request and response, and it's a branch of, or it's a topic that I'll say falls under application security, and we're going to do some programming on this payload encryption. It's very hard to come across a video that explains payload encryption and what our encryption is about. No, not encryption videos are there online, but as to how this relates to payload, in the terms of APIs and web services, is very rare to come across such a video. And I want to use this rare opportunity to also share my experience or what I know concerning. Let's forget the encryption bit, the payload side, and just talk about encryption before we add it to the payload. So we're going to look at encryption, then we now understand payload, or how payload encryption is done, be it in the light of request or in the light of response. Okay, so let's dive right into our video. So first of all, when you're transmitting data across the internet or on the network, let's start from here. That data is in raw text. So when I say raw text, what you send is what you get, what you see is what you get. If you type A on your computer, you get A. If you type B, you get B. If you type C, you get C. You don't get any other value aside what you type. So that transmission is raw text. So I have two computers, computer A and computer B, and then we all want to send data or some information to one another. Computers are information processing machines. In other words, they take input, do processing, give output, and do storage. That's the basic operation of a computer, and there are devices that help them to perform the operation. And then there's a software side of that. That's the programming bit that handles all the logics and stuff to give you the output that you want, or the storage you want to do, or be it whatever logic it is. So if computer A wants to send information to computer B, if he types A here, and by virtue of another field in computer space called networking, whatever he sends here has to come here, because if he sends A has to come here. Now let's dive a little bit into networking. The information that computer A and computer B are trying to send is all being handled by a certain principle or a certain model, which is the OSI model. That's the broader one, but the most restricted, or I'll say sexy one, is the TCP/IP model. So why am I getting to this? So I'm saying that the computers just don't talk to each other just anyhow. There's a model that guides that interaction. So if you look on this side, that's to our right, we have the OSI model. You can actually visit this reference to know more. I'll drop it in the comment section. Yep. So the OSI model just says that if any computer wants to send information to another computer, follow these guidelines, and then those principles or protocols is what you are going to use to understand payload encryption. Right now I want to understand encryption. So we start with the physical layer. The physical layer says that A and B have to communicate. If A and B have to communicate, there has to be some form of connection, or there has to be a link or a bridge. If two towns want to share resources, a town at let's say I'll pick Ghana. We have a town in Accra, probably Tema, and we have another town also in Accra, but we'll call it, in Greater Accra region we have Tema, and then we also have Tema to Accra. There's also Accra in Greater Accra. So if you are coming from Tema to Accra, there's a road that does that linkage, or that bridges that void or that gap, so we can all move from Accra to Tema, and that's a road. Now if you go to Volta region, if you are going to I think this is the top side or the northern side of Volta region. Once you get to Volta region, you are crossing that Dome Bridge. You are moving from one town to another town. You are going to another place. So that bridge is being connected by. That bridge was doing the connection. So that's what the physical layer does. We'll just rush through the OSI model. It's not a networking class. Then we have the data link layer. The data link layer just says that move your information with the help of knowing the computer's unique identity, and that's the MAC address. And so it helps to do hop-to-hop delivery of the network. So all this is happening just by typing A to B. It's all happening at once. Then the network layer is more of IP addresses, and we're trying to do an end-to-end delivery of our information. This is data link is more of hop to hop, but network is make sure that the food that you have has to go to Beverly Hills address number 1234 West something Boulevard, or I don't know, something of that sort. So make sure it goes there. That's the IP address I'm giving to you, or that's the address I'm giving to you of the recipient. So you have to make sure that the food goes to that recipient. And then we have a device that handles that, and that's the router. So if you pick this device, this diagram, we're all connected on the network, but the router is going to help us speak to our outside sources, because it's trying to do an end-to-end delivery. In other words, we know that we can move, we've connected physically, we know that we can do hop to hop. When I say hop to hop, ensure that you move the data hop from this hop to this device to that device. But aside that, how do we know that we're getting to that unique person? And that's the work of the IP addresses. And it may be confusing, but when you take your time to understand it, there are two separate protocols. One protocol can't do the same thing. One has to ensure hop to hop, that's I'm moving from here to this side to that one. Another one has to ensure end-to-end delivery. How do I know that it has moved from A to B? That's the work of the network layer. So in the network layer, looking at our IP addresses, just understand these things, because when your network gets bigger, you realize that it's all happening at once. You have a router, you may have several routers in a bigger network, and routers are more of like interfaces to the separate networks. So if one is doing an end-to-end, moving from doing a hop-to-hop delivery, then one has to ensure end-to-end delivery. So we are moving packets gradually, but how do we know that we are getting to the right place? That's the work of the network layer. And then we have the transport layer. The transport layer is just trying to say that the data that we are sending, and let's make sure that we don't lose any of that data, and let's make sure that there's a protocol that can ensure that whoever is requesting for that data gets that data. So it's more of it's more of transport, as it's more of making sure that the packets that you are sending goes to it has been received or has been delivered to that person. And there are two protocols. We have the TCP and the UDP. So these protocols ensure that there is a service-to-service delivery of the packet. Network just says make sure that this person gets that food. Hop-to-hop just says make sure that we are moving the packets or the frames or the segments from frames to segments. Make sure that we are getting it. We are moving those segments in a certain manner. If the network becomes very big, like something like this, you realize that it's all happening. But the transport is just saying, so if I've gotten to where I've gotten to, how do I know that all my data packets are being delivered and none has been lost? So just put that in your mind. There's no network, and then the top is our application layer. So the reason I'm saying all this is that as the data is going from moving from physical to application, or from application to physical, that's physical from here to here or from here to here, it's all raw text. Nothing has really been added to it to ensure that if you are sending sensitive information, your data is not being tampered with. So this is why I'll bring the application security terms, or the three legs of a stool for the application security, which is confidentiality, integrity, and availability. So we have different types of data we'll be handling. It could be sensitive data, some data are sensitive, some data are not sensitive. So based on the application that we are building or designing, you may want to make sure that some of that data follows a certain guidelines, or your application is not disrespecting any of those guidelines. And those guidelines are the C.I.A, confidentiality. Those who have access should have only access. Those who don't have access shouldn't have access. Integrity, the data that you are seeing shouldn't be tampered with because it's not editable. It's supposed to be as it is. And availability, make sure that the data is always available, and that can be used for whatever purpose it has to be used for. A good example is if you are someone that uses mobile banking, or you are somebody that has enrolled on mobile banking services. You realize that mobile banking services those applications tend to follow some C.I.A principles. The account balance you see on your mobile app is supposed to be confidential. Only you are the one supposed to see it. So if your PIN, or if the application hasn't been designed properly in such a way that you enter your PIN, it gets stored somewhere whereby someone can also come and enter the same PIN, then it breaches C.I.A. Or if your PIN, the application hasn't been designed in such a way that it's broken, that anyone can enter any PIN, and then it gives you access to your account statements, or to the banking services you want to transact or you want to operate on. So if that's the confidentiality side of that, so there are ways of doing that, maybe user role access and restrictions and credentials. So many things can be done there. So let's just drop it there. It's okay. Now the integrity part is that make sure that if I'm checking my account balance, it should be integral. So in other words, what I'm seeing there shouldn't have been tampered with. If I bought about $100 and I bought something of 10 cedis, my account balance should say 90 cedis. Forget bank charges or whatever, or other fees. If it's 100 and I bought something of 10 cedis, it should be 90 cedis. It shouldn't be 100. It shouldn't be way less than any amount that was debited from it, because it could mean that my data has been tampered with in the line of who knows how. But that's the integrity side. Another way of knowing integrity is if someone's health record says that he's diabetic of a certain disease, or he has HIV/AIDS, it should be integral. You shouldn't be able to tamper with that data or that record. If you're a client or you're a doctor viewing a patient's record, first the confidentiality comes in when only a senior doctor can view a certain range or a group of patients' records. That's one way. The integrity part is that all the records that are being shown, there should be no way of tampering with that data because it's sensitive data. And then the availability side is if I go to the mobile banking app side, if I go to the banking app, I should always be able to see my account balance. There shouldn't be a case whereby I go and I can't see my account balance. It's not, it causes fear and panic. You understand? If you're a customer that are transacting with a mobile app. So that's the availability side of it. So in a nutshell, what I'm trying to say is that all this moving data from A to B and the network map or the connectivity taking place, sharing data, obeying the OSI model is all raw text. That's one. It's just raw text. Everything is raw. Nothing has really been put in place because as a computer as it is, it's a dumb box. If you don't do something to it, it will act just as it is. If you don't put data, it won't process. So unless you do something or unless you kick off something, then it starts obeying certain principles or certain rules. So that's the whole explanation of the raw text I'm trying to give. Okay, so I made mention of the C.I.A. application security networking OSI model, and it's just the basics that you need to know about this. Okay, so now let's look at a demo of just encryption. Remember, I haven't made mention of payload, request or response. So let's just go. I have a lab that I've set up for encryption. We'll write some small code to understand the whole encryption bit, then we move to payloads. And I think this video or this series will be like I have 2 more episodes to shoot. So I'm going straight to Eclipse, my favorite ID. So let's just be patient while the IDE loads. So I hope it makes sense now, the encryption and the raw text, and how information is moving from, data is moving from 2 separate devices, or it could be a mobile phone, it could be game console that has Wi-Fi, it could be anything at all, as long as it's a computer and can be connected onto the network or be the networking principles or the OSI models. It's perfect enough to say it's network enabled device. So always keep the C.I.A. in mind because the C.I.A. is just the guidelines that helps you to know that an application has properly been secured. Oh, I need to skip along. Let's give it a second. Right, so let's just go straight to doing what we have to do. So this is a small lab I have to do encryption. I'll make mention of 2 types of encryption. We have symmetric encryption and asymmetric encryption. Symmetric encryption, before that, what's encryption? Encryption just simply means concealing your information. For example, if you're a lover boy and then you are sending messages to your girlfriends, you wouldn't want to make a mistake of sending a message that has to go to Jacqueline, to maybe Taylor, or to Chloe. No, you don't make that mistake. So the message you're sending to Chloe, you conceal it with them. You conceal that message. When it goes to Chloe, removes the seal from it and gets a message. Or if you are sending a message to Jacqueline, you conceal it with Jacqueline's something. Then when Jacqueline gets, she also removes the seal. So just the way of understanding encryption, just concealing your data for certain reasons or certain purposes. So if you put it in line with the C.I.A., then fine, it makes sense. That's what I mentioned earlier. So it depends. Just think about it just like that. That's how I understand some things. Alright, so we have symmetric and asymmetric encryption. Symmetric encryption means that if I'm sending a message to Jacqueline, when it goes to Jacqueline, I use the key, or what I use to conceal the information. Jacqueline also knows that wrapper. So I use the wrapper to conceal it. Jacqueline knows that this is the wrapper I use, so she's able to remove the seal from it. In other words, the key I use to seal the message is the same key that Jacqueline used to read the message. So what I use to encrypt or conceal the message is what Jacqueline is also going to use, the same key. Perfect. Now, asymmetric is 2 different keys. If I'm giving a message to Jacqueline, and I also have Josephine, and I have another girl's name. Let's just pick another girl's name. I don't know, I'm not a girl's name. Rihanna. Okay, so Jacqueline, Josephine, and Rihanna. I want to send a message to Jacqueline. First of all, I conceal the message with I'm giving a message to Jacqueline, so I want Jacqueline to read my message. Fine. So I'm going to use my key to conceal that message, and Jacqueline will be able to decrypt that message based on a certain private key. Okay, so this the scenario. Let's just clear it up. Now it means that there are two keys, a public and a private key. My private key, the private key is what can only decrypt, and the public key is what I use to encrypt. Just put that in your mind. Public keys will be used for the encryption, the private key will be used for the decryption. It comes as a key pair, so whoever is writing the message has to have a public key. Whoever has to decrypt the message has to have the private key, and there has to be the owner, so it has to be from an originator who is sending to who and who needs to read what. So if I need to read an information, and then if let's say Jacqueline is sending me a message, now let's do it this way. Jacqueline is sending me a message. Jacqueline is sending me a message. So Jacqueline will seal the message with what? With my public key. When I get the message, I unseal it to what? My private key. Because Jacqueline is sending me a message. Now, I'm sending Jacqueline a message. I'll conceal the data with Jacqueline's public key, and then she unseals the message with her private key, because it's our lover message, you understand? You know, we are communicating in love terms. So that's what it means. So we all have keys. Jacqueline has a public and private key. I also have my public and private key. Whenever I want to talk to Jacqueline, I'll give her my public key. Whenever Jacqueline wants to talk to me, she'll give me her. So this is, if I want to send Jacqueline a message, Jacqueline has my public key. So Jacqueline will use my public key to send me a message, and I'll decrypt my private key. Fine. Now if Jacqueline wants to send me a message, Jacqueline has my public key. Jacqueline will conceal her public key with my public key, and I'll conceal with my private key. I want to send Jacqueline a message. I will conceal the data with Jacqueline's public key, because I'm sending it to Jacqueline, you understand? So I'm writing a lover message to one lover, that's Jacqueline. So I'm saying, Jacqueline, I love you from the bottom of my heart. You know, they are all the girls in the world, but you are the most beautiful and whatever. Just take it like that. So I'm going to give that message to Jacqueline. So Jacqueline, I'm locking it with your public key, because it's going to only you. I'm not going to lock it with Ahmed's public key or Josephine's public key, and then it goes to you, and then you can't unlock the message, because I've used Ahmed's key or Josephine's key to lock our message, you understand? So that's how Jacqueline will know that someone has maybe multiple girlfriends or something. Please, just for understanding's sake, please. Alright, so now let's go back to our thing. So I'm not going to type anything here. There'll be something down, just wait down here, you see the summary. So let's go again. So Jacqueline has to send someone a message, or CodeFilms a message. Jacqueline says, someone, you are the best guy I've ever met. So Jacqueline says, I'm using your public key to encrypt it. When it comes to you, you'll be the one who can read our message. Sweet, that's good. Now someone wants to communicate back to Jacqueline. Jacqueline, you are the only girl in my heart, the only girl in my life. So I will write it, and I'll say, Jacqueline, I've used your key to encrypt it. Jacqueline gets it, and she can decrypt with her private key. Simple. Now I want to talk with Josephine. Josephine, you are the only girl in my heart. I can't use Jacqueline's key to encrypt the message. That's Jacqueline's public key. No. But if I do that and it goes to Josephine won't be able to decrypt with her own private key. So she know that no, something is wrong, because you are the only one I've shared my public key with. So how are you using another girl's public key to encrypt my message? and you want me to use my private key to decrypt the message, it's not working, meaning that something is not right. You understand? So that's the asymmetric encryption. So asymmetric, we have RSAs, public and private key. Those three people that brought it, I'll put their names down there, or just put something down there. Yeah, and then the symmetric one is more of AES, Advanced Encryption Scheme. But AES has so many modes. CBC, ECB, with some padding, with no padding, a whole lot. But a good example of symmetric is AES, one public key or one secret key to both encrypt and decrypt, and then one private key, and nothing, and then asymmetric, public and private keys. So two times two keys, the key pair, and the number of people you want to communicate with. So you can do the math, either 2 to the power n or something of that sort. Yeah, 2 to the power n, if I'm right. Yeah. Okay, so now let's understand encryption now. So I want to create a simple program, and I'm going to show you using advanced encryption scheme, advanced encryption, that's AES. So I'm going to take some input form. So we're going to get transaction information or data. We're going to get some transaction information or data. Then we're going to see it as it is. So first thing we say, sysout. Just enter your bank details. So something like your bank details is very sensitive. There are some part of your bank details that you don't enter your bank details. So we're going to get that input. So string bank details. Let's just leave it like this. I'm not having seen anything. I'm going to get from the input. So scanner.input will be equal to scanner system.in. It has to be new. I'm creating a new read input, and I'm going to say that input dot next line. I want to read the whole line, and I'm going to save that in bank details. Okay. Now let's just make this is what interesting, just to make it code safe. So this is what we're going to get. Then later we're going to print it out. So let's print out the bank details we captured. We're going to call it here. We say bank details captured. Alright. So this is an application we've written, and somebody is entering his bank details. It's raw text. Forget the communication side now. So back to our slides. This is just computer A. This is just computer A. Computer A hasn't yet sent it to computer B. Let's run this. So enter your bank details. So we're going to enter our bank details. No, bank details are sensitive, very, very sensitive. So because of this, there's also a framework or a process. We call them the PCI, the payment card industry, PCI DSS, and data security. Yeah, I'll put all these abbreviations down. This video is just for explaining certain things, but I just want you to know that if you are going heavily on this understanding, you just don't do anything. There are bodies and people and frameworks that make regulations and regulators ensuring that people's data don't just get tampered with easily. So encryption has to come in. So if I just enter my bank details, probably the most sensitive part of my bank details could be my CVV and my PIN. So I'm going to enter a random CVV and then I take my PIN too along with that. So this is what I've entered. So you see what I entered is what is being shown. So when I say bank, sorry, maybe card details, so maybe my bank details or card details, or even only my bank details. So I've entered my PIN and also my card details. So account number, everybody can give their account number, but there are some parts that are sensitive. If you haven't worked in a bank or any financial institution, you don't know which parts are sensitive unless you are quite curious to find out which ones are more sensitive. But if you are from an IT background, you know that certain things are logged in a database, so you know which ones are sensitive and which ones are not sensitive. So this is just one aspect. But if we don't want to go with this, we can also go with a health, from a health direction, whereby some information from the health field are sensitive, some are not sensitive. So you will be able to know which ones are sensitive or not, like health records or HIV status or your gender type or your sexuality or your sexual orientation. Those things could be sensitive. So if computer A wants to know, produce that data and send to computer B, it's going to go as raw text, and because it's raw text, there's some way of getting that data. We're not going to talk about hacking or cybersecurity here, but I'm just making you understand that as long as it's raw text, we can be exposed. So in our next video, we'll see how that works. That's why I've explained the OSI model so extensively, because there's another video that will try to understand how is it possible for someone to sniff over your data. As long as it's raw text, there are so many ways of doing so many things. So, and even in the router space, just everything is raw text. So I'm sending information from here to here and then just transmitting information. Someone can build certain software or program to just pick the information. It's possible, because when you get deeper understanding of the OSI model and how the data is moving from 1 to 7 or 7 to 1, you realize that each time it moves from one layer to another layer, there's just an addition or it just adds on top like a stack, or it builds upon it. So it's just what you produce that it just keeps moving up, and that's all. So you can actually interrupt or interface or interfere or penetrate through programming, and it's very possible because of the way the data is being moved from 1 to 7. It's very, very possible. So if you want to know how that, you have to maybe go deeper into the OSI model. Probably maybe in the next video I'll see if I can just get a little bit deeper. So let's go back now. So you see, this has no form of encryption. So if we're now to send, so now let's do something. So sending bank details to maybe teller to regional office. So we are loading, then we do connecting to the network. connecting to regional office IP address. I'm gonna put it down here. So maybe our domain. So maybe we call that one save dot. We'll call it save dot transfer dot details dot com. So let's call it unsave. There's a unsave bank dot transfer. So it's just a domain that I've produced over here, something of a domain. So this will do some resolution, DNS resolving to get the IP address and stuff. So then we send the data. So if we run this again, there's no network connection here. That's why you're not going to see anything moving. Just for you to appreciate the logic where I'm coming from. Later when we do the API side, we'll be able to have a better understanding of things. So connecting to regional office IP address, then the data will be sent when the connection is being established. So HTTP client, so go to this is an interface. It's an abstract class. So we go to close server. HTTP client, then just use client dot send. So this is just an example. So when we build our request, HTTP request, and then the body. So I'm just doing something HTTP request, and then we call the request, and then body handles, then response. So we are going to send the request. We are not getting to the request side. I said it's going to be about explanation of things. You just follow, please. So sometimes this sort. Right, so let's see what type of body handlers. We are just looking at strings for example. Okay, it's not generic, so you can leave it there. Okay. Body handler, sorry. Body handlers. Yeah, so don't worry about initialization and everything. So I'm just making some, so we are sending data to that, so we'll be able to know where we are going to send our information to. So send, request, response, and right. So just the basic understanding of things. So you see, everything is raw text. So if you are going to send this, it's all going to be in raw text. Later we'll look at the communication. Don't worry. Right. So just for you to understand that it's all raw text. So now let's add the encryption now. So the encryption comes in whereby, as I said, we have asymmetric and symmetric. So we are looking at symmetric. So I have a method here that does SMS encryption. So in this method, if I go to the signature, I need a message, a secret key, and an IV parameter, and this is AES. So you get a secret key and an IV parameter, and the actual message that we want to encrypt, because we don't want it to go in raw text. We want it to be encrypted, because we've explained why we need it to be encrypted. Because of C.I.A, it can affect the integrity of the data we are sending. It can affect just the integrity. Just look at the integrity side of it. Forget the C and the A. This one is purely the integrity. The data can be tampered with. You understand? If we are streaming or we are trying to get our bank details, and then in that process someone's able to tamper with the information, it's not good, because it's going to affect customers' reaction. So we're going to call this method, and this method is good. We need to generate a secret key and an IV parameter. So we'll have a lab that will do that, and then we just pass the message and then to be encrypted. The body definition is here, how it's being done. Don't worry about that, just understand this for now, that is going to do encryption. Okay, so let's call our encryptor to do the encryption. So sending bank details regional office, connecting to the IP, then we will do SMS. We need an instance first, so AES equal to AES dot do SMS encryption. So we pass our bank details. We are going to generate our secret key for this transaction. We are going to generate the IV parameter. The IV parameter is just like another way of, is that an extra pseudo factor that is needed for the AES encryption. So we have the actual secret key. That's what we are going to use to encrypt our message or build our cipher. But the IV is like I like to say like a salt or another handler that just helps you to know that your AES is being done. Yeah, so we just see like another parameter that is just needed. I'll call it a salt handler, or some of salting or extra seasoning. Yeah, so that's just for you to know. But it's not another key that you like, it's a public or secret key. No, it's just extra salt to cause the encryption to be more difficult to hack or crack. Yeah. So how do we get our secret key in IV parameter? So I have another Java class in main. We're going to do that in this app section. So we're going to get a secret key. So secret key will be equal to, we'll call our AES method here, because there's a class, there's a method in AES that helps us to generate keys. So I'm going to call the AES.generate key. This will generate our secret key for us. When you go into that method, there's some definitions that explains the key size and everything. It's very technical. So just the basic of encryption, just for you to know AES encryption. So AES encryption, one key to the encryption. So the other ones is more of strength and making your data more encrypted. You know, the number of the key lengths and the key size. Just understand, if I'm sending something to one girl, the number of wrappers I'll use and how I'll cover it and what I'll do to conceal it, you know, all these are just to make sure that no one can read our messages, so, or no one can unconceal the gift I'm giving to her. So I'll put solid tape, I'll put glue, you know, just to make the data more secure, more encrypted, and one simple as that. Don't think far. So it's IV parameter, and then if you, well, I'll put a link down for AES encryption. So if you go and read that plain data, just know that it's just to make your data more encrypted. So there are factors that are influencing it. That's cybersecurity and why they are advising that. This one is IV parameter. So AES.generate IV, and then it needs an instance of IV parameter spec IV. It's equal to this. We are going to use this to send our message to do only bank transactions. So let's print the keys out. Let's print the key and then IV parameter spec. Okay. Let's run this now. Oh, there's an error somewhere. Let's clear what this one of the errors. Oh, it's in this class rather. Sorry. Okay, so let's undo this. Okay. Oh, yeah. So it's been able to generate that. Need it in a different form. Yeah. So we need to actually see the values that are coming outside. So generates key returns a secret key, and this one too returns an IV. And from what I know, that's it comes as bytes. So you want to convert a data you are receiving from byte to a more readable form. So let's encode the message from bytes to base 64. So So we'll call a method decode AES dot decode encode the message encode. So we're going to encode the message. That's take it from one form to another form. So key dot get encoded, and this will give it to us in key as base 64. Just say key as string, readable string, and that's what we'll print out here. And then we do the same for string ivstr as dot encode iv pointer dot get iv. Get iv will give you the iv. And the reason it's string all this is because the class is static. Let's just make it static reference. Okay, now let's print out the key and the iv. Let's see what values we get now. So we are just encoding it because the generic key will come as bytes. Oh sweet. So these are our keys now. So this is the key and this is the iv parameter. So we are going to save this. And this one too. Okay. So now let's do our AES. So we'll use this key to encrypt our message. So that will be our secret key. Now we'll use this one to do our extra pseudo stuff or padding, whatever matrix, whatever sorting we want to do or seasoning. Okay, so let's just handle the exception. I'll throw it out for now. I'm not going to handle it. And then I'm going to say string encrypted bank details. So we'll print that one out. So now, which means that now when I'm going to connect to the original office, we'll be sending encrypted data. So we'll say sending encrypted data to original office. And then maybe it has a code UIO 12. So that's the original office code. And this is the data assembly. So let's look at what happens now. So let's enter our bank details 789. Says 789. I've entered my bank details and maybe my PIN. So my card and my PIN details. So send encrypted data to original office. This. Don't worry about this. This is coming from the encryptor. So this is the data it's sending. This is the data is sending. Alright, so some of this, so that's all that we're supposed to do. So it goes in this form. This is base 64 string. Sometimes it goes as hex. Hex looks more sexier than base 64. So let's just go to our encryptor and see how to do. Let's change something here. Encode them. This byte and return as base 64 string. Or you can do byte to hex rather. So instead of just doing this, I'll just change this small and I'll copy the same thing. Not just copy but use the same logic but call a different method. So I'll do bytes to hex rather. So bytes to hex will give us the data in hex so that it looks more encrypted. This one just looks just one way. It's just a basis for string. It's not really showing any form of encryption. It does, but it's not, to me, it's not looking more readable or more encrypted. encrypted. Let's just run it again. So this is much better. So with this you can see that the data has been moved from bytes to hex. Yeah. Okay, so you can still use the base64 string. There's nothing wrong with that, but there are two that basis for hex, but just stick with the hex for now. Yeah. So that's the data that's been encrypted. So now when it goes to the reader office, it has to be decrypted. There's a question ringing in my mind. Why? So which one should I use? Base64 or hex? Wow. Okay, so I'll explain that one later. So you just, for now, I'll say just use the one you be comfortable with. Any of them can do encryption. You don't see it as raw text anymore. Just feel free use anyone. But there's a reason why I think yes, if you go with hex more, the data looks more scattered or more encrypted with hex because of the hex has a hexadecimal numbering system. I think it's 1 to is this 0 or 1 to 16 or so, but after a certain number it starts with A, B, C, D. It changes a whole lot of stuff, so you can represent more information with the hex. So instead of you just doing ones and zeros, you can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then A, B, C, D, all the way to F. So that's 16. So you have more. There's more. You can handle more. You can handle heavier number construction of numbers, alphabets, and other stuff. So it's just because the numbering system is huge. That's base 16. It's not just ones and zeros, plenty ones and zeros. No, everything can be consolidated in a nice way. Yeah, that's the explanation. So take it like that. But if you don't, you go and read more. So that's coming from me. Yeah. So now let's decrypt it. So when it goes to original data, it has to be decrypted. So we do that on the same console. Right now, I haven't done any transmission to any other network. We haven't sent it from A to B. There's no connectivity whatsoever. We'll do that one in our CodeFilm. So now let's see it as the data has come. See data coming from UIO212. So we'll let our program wait for a while. And that's like 3. Let's use 5 seconds. We'll wait for 5 seconds. And now throw all exceptions out. So data coming from UI, then we are going to decrypt it. So decrypt the message, and then so we are going to call our decryptor. So we'll say AES.do AES decryption. So to do the decryption, we take our encrypted bank details that we receive, the same keys. So now let's make our key for, let's call this one encrypted bank details key, and that will be equal to this. We realize that if we do tamper with the key, it affects our program. And then string encrypted bank details IV. Okay, Java programmer, I know that we can make this all static reference final in our class. So it's the key first. So and look at our method and our method signature. open coil, open declaration. Oh, let me just step into it. So the message signature says message secret key and then method signature says message secret key and IV. So this is our method signature. We need the message, the secret key and the IV parameters. So let's pass them as they are. So encrypted bank details key, our IV, and then our message. That's our bank details, sorry. Yeah, that's the variable. And let's just move all this from here to the class and make it final. It's just good programming practice. And make all this final. And let's refactor this. Call it make it capital. Okay. So that's a good job done. Okay, so why is it crying now? Oh, so final static. Final by final is not final. So okay, I think we have to even show this one. If it's not final, if it's just final and then it's a string, we should be able to call it with a class. But I'm not calling it with anything, so that's why I was screaming. Should be able to call it with an instance of the class. So when we want to decrypt too, let's look at the method signature for this. Says an encrypted key and a secret key and an IV. So we'll take our encrypted key. Sorry, an encrypted message. Sorry, it will be an encrypted message. Secret key and an IV. I'm going to that right now. Yeah, outlines here. Of course, we are inside the class. Okay. think we are okay now. Wow. This one is just cutting off. I'll continue. So I'm going to show you the message. And I'm print it out. So yeah, we'll see what our encrypted message was. So let's run our program. So we have sent the encrypted data. We are waiting for 5 seconds. Then we'll decrypt our message. So it has realized that there's something wrong with the decryption. So let's go and find out what the issue is. It seems there's an issue with the IV. Let's confirm that's the right IV we are even using. We saved it somewhere. The same. We are not calling the right decryptor. So I have to check that one. Okay. Yeah. Right, so is the output. Remember initially this was coming in base 64, but now I'm returning it in bytes to hex, so it's complaining. Let's go back to the base 64 and work with that base 64 string. And let's run it again. Sorry, it's wrong. Let's kill the program. Let's run it again. So enter your card number and so this is our encrypted message. We are now going to decrypt it. Voila, so it says it gives you the same decrypted message. So what was encrypted is what has been decrypted. So that helps us just to understand that our message has been concealed and not concealed by the right key. If I do tap let's go and tamper with just the key. Let's just move a character. Let's move one character out. You realize that it's going to complain. Okay. Because the same key is going to be used on a static, it will not really complain unless I pass in a different character set here. If I do pass something different than the original, let's go back here. So this is the original. I do pass something different than the original. message will not be able to decrypt to throw an exception to a single message. So you see that the last thing does not have enough valid bits. So okay, it's just complaining about the bit size. Okay, fine. Let's just change it further. Let's change the bit size. There are some bytes in key size definitions. That's the AES. It's not going to be. It's no explanation. No explanation will be given about it. Just go in. I'll drop an article for you to read more about that. And research things later in our video up. Here we just want to understand why we are doing encryption. So let's run this again. Good. So it says that such issues can arise if a bad key is used during decryption. So we are not passing the original key. So it's complaining about bad padding. So that's it for this CodeFilm. Just understand this encryption and raw text. So realize that we won't be able to decrypt it with the right key. So we are not using the right key. So that's all for just the understanding of the encryption. I think the only thing that really took me off is the static that has to be added. I don't know where my Java has gone to. Then I think this is a good CodeFilm for you to get started with encryption. So that's it for this CodeFilm, and stay tuned for more. Thank you.